I'm Chris Paget. I am the Chief Hacker from Recursion Ventures, and I'm here to tell you all about the internals of the Microsoft Windows Vista final security review. So a little bit of full disclosure before I begin, just in the interest of kind of clarification on a few things. Obviously, I was paid by Microsoft for my time on the Vista engagement. I haven't accepted any Microsoft money since then. Microsoft certainly had, no payment for this talk exchanged hands. They haven't given me permission to give this talk. I did give them a copy of the slides about a week ago, just as like a little heads up. They requested one minor change. It actually wasn't a big deal. It didn't change anything for the essence of the talk, so I was happy to make the change. Also, from full disclosure, I have no documentation to back up any of what I'm going to talk about during this talk. That was actually a condition of the non-disclosure agreement, that all of the documentation had to be destroyed. So everything that I'm talking about here is from memory, and feel free to take it all with a rather large pinch of salt if you think I might be misremembering things. Another thing to clarify is exactly which terms of my non-disclosure agreement have expired. As far as I'm concerned, everything that I want to talk about during this talk, I'm free to talk about. There are still some clauses of the NDA in effect. I'm not actually allowed to talk about specific details of specific vulnerabilities that we identified. The only real disappointment for me on that fact is that I cannot actually tell you how many bugs we found in Windows Vista. Not allowed to tell you that. But I can't actually remember the number anyway, so it's moot. But yeah, as far as I'm concerned, everything that I want to talk about, I'm free to talk about. I'm not holding anything back from here. But at the same time, if you're expecting me to be dropping some zero-day, you're in the wrong talk. So a little quick demo here. Where are we? So this is a little application that I wrote just at the end of the Vista engagement. Counts down the exact number of seconds, corrected for whatever time zone you're in, until the Vista NDA expires. Apparently it has an integer underflow bug. Hey, so either it's... yeah, that's just not right. So yeah, suffice it to say, my NDA is no longer in effect. So, okay, a little more full disclosure here. First off, I don't run Windows wherever I possibly have a choice. I have two Windows machines on my home network. One is a dual boot machine that I use just for gaming. The other is just a little laptop that I use to run some hardware tools that just don't have open source drivers. That's the only two Windows machines that I have, and those are by necessity. In comparison to that, I have 30 or more active servers at home, my laptop, various places around the internet, all of which running some flavor of Unix. I am a total Unix head. I do not like Windows. I do not use Windows. Not a fan of it at all. I even take it as far as recommending that people switch away from Windows in a lot of different contexts. In 2002, I actually released a white paper documenting what I called shatter attacks, a new class of attacks against Windows, basically using GDI messaging for local privilege escalation. I called it shatter attacks because they break Windows. So, this was obviously a few years prior to being brought in on the Vista engagement as well. So, there's a little bit of history there as well. From my perspective as a hacker, there's just too many things that Windows cannot do. I need my operating system to do, a bunch of things that Windows just can't do. Some great examples: SU and chroot. I once implemented SU on Windows. It was a spectacularly ugly hack that introduced a really unpleasant race condition. It worked, but it wasn't pretty. Suffice it to say, if you're used to things like SU and chroot, don't ever expect that to ever appear on Windows. It's just not capable of it. The security model of it just isn't designed with things like that in mind, so it isn't ever going to work. Other reasons I don't use Windows: I need an OS that scales the way that I want to work, and need it to scale with full functionality. So I don't know, how many folks saw my DEF CON talk last year where I was messing with GSM base stations. That was all on a Linux laptop, and I can take all of that code and port it directly to my Linux cell phone, and it works. It just works. Everything is there. It's all present. You've got a full Linux kernel there. So, anything that a laptop can do, a cell phone can do nowadays. Sure, you can run Windows on a cell phone, but it doesn't have full functionality, and that bothers me. That's a limitation that I can't deal with. The primary reason, to be honest, why I don't use Windows is because the whole clippy mentality annoys me. I don't like being treated like an idiot when I'm using a computer. To be honest, Windows, I don't know, there's a very fine line between extremely usable and treating you like an idiot, and sometimes I think Windows gets it slightly the wrong way. Great example is Clippy. This is what I mean by the Clippy mentality. Treating you like you really don't know what you're doing. It bugs me. I'm not a fan of Windows at all. So, having said all of that, I now want you to forget every word that I've just said. Every single word. Just put it completely out of your minds, because we are not talking about whether or not we like Windows. We are not talking about the functionality of Windows here. Functionality is not security. My views on how usable or functional or the user interface of Windows, it's irrelevant. We are not talking about that at all. My personal viewpoint on Windows is purely technical. It's got nothing to do with the security of Windows, and I just want to make sure that I'm absolutely crystal clear on that. My viewpoint on Windows has no impact whatsoever on my view of Windows as a secure product or not. So the important question is not, did we like Windows Vista? Because let's be honest, we already know the answer to that. You don't need me to get up on stage and rant about Vista to decide that. The important question is, was Vista secure? Very different question and a very, very important distinction. So, was Vista secure? Well, there's a very popular cliche in the security industry that security is a process, not a product. What we mean by that is that security is an evolving thing. It's a mentality that you get into. It's a way of responding to things and a way of thinking about things. It's not just a box that you drop in your network somewhere. So if we ascribe to that theory, then whether or not Vista was secure basically comes down to how good was the process for securing it. So we're talking about the very final stage of this process here. My involvement was in the final security review, the FSR. The FSR was supposed to be a final once-over before release, a last opportunity for us to find any really glaring bugs, anything that was really, really potentially critical that we really wanted to fix before release. The FSR was the absolute last-ditch scenario in which we could do that. We had full access to everything, and I do mean everything. We had a really spectacular team working with us at Microsoft that anything that we needed, whether it was documentation, whether it was source code, or whether it was a developer that wasn't returning our phone calls because we had some tough questions for him to ask. The folks at Microsoft were right there giving us everything that we needed. As far as I'm aware, this was unprecedented as far as Microsoft were concerned. They've never done it before we came along for Vista. So this was real groundbreaking stuff for them. The only thing that we didn't have access to was the DRM code. DRM in Windows is protected very, very carefully. As far as I understand it, there were other people on the team that did look at the DRM code eventually, but had to sign even more NDAs that were even more restrictive and harsh. From my perspective as someone that was kind of kept away from the DRM code, it was about 6 months to a year after the FSR finished that Windows Media DRM was broken very, very badly indeed. There ended up being a cat and mouse game between Microsoft and the crackers that they cracked the DRM, and Microsoft broke new records in how fast it put out a patch for DRM. And then the attackers broke new records again for how quickly they broke the patch, and it went back and forth, and I couldn't help cracking a smile because I had no opportunity to help out there. So To some extent, that was self-inflicted. So we called our final report. The reason I called this talk the good, the bad, and the ugly, this is what we called our final report on the security of Vista. We got together as a team and we said, let's brainstorm out a list of things that were good, things that were bad, things that were ugly. We got 10 of each. But to be honest with you, looking back on it now, if I was to rewrite that report today, it would be more like, here's a few things that we disagreed with. Here's a few bugs that we think you misclassified. Maybe a couple of process glitches here and there that we thought could be smoothed over. But then beyond that, a couple of little minor side effects, but here's a humongous list of everything that you did right. If I was to rewrite that report today, it really would be a case of here's a few odds and ends that we disagreed with, but basically you guys did the right thing here. I wanted to put this slide in. I actually added this slide because I wanted to make sure that this point got across before you all lost interest in my boringness. Microsoft's security process, in my opinion, is spectacular. SDL is a phenomenal process. I strongly recommend it to everyone that I ever have the opportunity to do so. Microsoft has really set the gold standard for how to implement security in a large, complex product through SDL. Please quote me on that. Please do. Microsoft has a very, very bad reputation for security, and in my opinion, it's very much undeserved. So let's put this whole thing in a bit more context. 5 years ago, that's what we're talking about here. We had seen Code Red, Nimda, and Blaster. Blaster was, fairly recent. So, certainly the concept of a worm was well established. But, if you think back to BlackHat a year ago and how much our world has changed since then, 5 years is a long time in InfoSec. We hadn't seen Conficker or Stuxnet. We hadn't seen any of the really, insidious malware that, things that survive you formatting your hard drive, anything like this. We hadn't seen ransomware. It was just emerging as a concept. The idea of either demanding a ransom or knocking someone's website offline, or this malware that encrypts files on your hard drive and makes you pay to decrypt them. All of this stuff. The entire concept was new. The new hotness that we were excited about when we turned up at Redmond was local ownage via DMA. I don't know if you remember, but a few years ago, someone published a Linux distribution for iPods. iPods having a FireWire port. The idea was that you could plug your iPod into someone's FireWire port. It would read and write kernel memory directly over the FireWire port, because DMA gives you basically read-write access to physical memory. And the upshot of it is you plug the thing in and you hit enter and you're logged in. So, complete local ownage. This was the stuff that we were dealing with at the time as being new and interesting. LulzSec and Anonymous hadn't come about yet. The entire concept of hacktivism didn't exist. TJX, Google, RSA, all of these APTs, even APT hadn't been coined as a term of art. We were still calling them skilled determined attackers back then. And yes, I was a different gender back then, so lots of things have changed in the last 5 years. So what were we actually brought in to do? What was the meat of the engagement? Well, by the time that we arrived on site, Microsoft had completed a high-level risk assessment. And the way that this worked was they pushed out a questionnaire to every team with very simple questions on it. Very, very high-level, very simple questions. Do you handle credentials? If you can tick no on that box, then you are lower risk than anyone that ticks yes. That's kind of the level of granularity that we were looking at in that risk assessment. Do you process network traffic? If you don't process network traffic and you don't handle credentials, why are we doing a security review of you? Do you know what I mean? That's kind of the goal that we were getting to here. So by the time that we turned up, Microsoft had completed this process and come out with a big, long, prioritized list of everything. And had determined, these are high-risk items, these are medium risk, these are low risk. Obviously, we attack them in order of risk. So for each feature, and a feature here is a fairly atomic group of functionality, So for each feature, we'd start out with the documentation. We'd review the threat models, review the data flow diagrams, review whatever documentation the teams could provide. We'd then go and interview the teams. So we'd sit down with the project manager and we'd go through their architecture with them. It's actually a very, very interesting thing to do because you develop kind of this sixth sense for things. That, you know, when someone starts kind of shifting uncomfortably in their seat, you know, you're getting towards a topic that they really don't want to talk about, so you need to push that a little bit harder because there's bugs there, guaranteed. So we interviewed the project managers, developers, architects, you know, basically anyone that we thought would be useful to gain an understanding of the feature and how it worked. We then go back to the source code. If we, you know, had any concerns about possible implementation bugs, or, you know, maybe the answers from the team are a bit woolly, we'd go back to the source code and, you know, spend however long it needed to do a full source code review. And throughout the process, we're filing bugs as we went. So, you know, Microsoft had this continuous feedback system of, you know, how is the engagement going? How many bugs have we found? What rate are we finding bugs at? What's the best features? What's the worst features? All of this stuff, kind of continual data gathering. Our scope, this is kind of an interesting point, actually. For Vista, our scope was everything that had been added to the operating system since XP Service Pack 2. So essentially we were testing everything that was advertised as new for Vista. But if you think about it, what about the, you know, 100 billion lines of legacy code, or, you know, however much code it is? I know that the machine that we were originally given to host a copy of the Windows code base didn't have enough hard drive space. We had to, you know, upgrade it just to deal with the volume of source code. So, you know, why were we confined to just new code? Well, the thing of it was originally scoped as a small engagement. The engagement started out as a team of, I believe, 4 people for 3 months. At the time, Microsoft had you know, recently completed this very interesting internal study that had come out with a price point of $250,000 per security bug. So they'd actually done a lot of data gathering internally about, you know, how much developer time costs and how much QA time costs and how much impact does a security bug actually have on Microsoft's reputation and how much does that cost. It's actually a really complex process to try and figure out how much a security vulnerability costs you to patch it and to QA it and to deploy it and you know, all the rest of it. But if you go through the process and you come out with a number like this, it's a spectacularly useful tool. Because you can do things like saying, well, you know, let's say for the sake of argument that us as consultants were charging $1 million. If we had found 5 bugs for that $1 million, Microsoft had won overall. So it was great having this $250,000 figure because there was no arguing about it. That had already been, you know, validated and accepted, and all of the logic for it had been agreed upon. So it was a done deal. And any time that you know, we found a bug, it was like, hey, this is $250,000 value, if need be. But in actual fact, the idea of this value of a bug had propagated so widely that we really didn't have to worry about it. You know, when people hear the term, you know, a security bug costs us $250,000, they pay attention. So overall, yeah, it was kind of a no-brainer for Microsoft. They you know, had this initial team for just a few months. They saw the number of bugs that we were finding, and basically on the spot at the end of the engagement, tripled the duration of the engagement, tripled the number of people on the test. So basically, you know, because of this $250K per bug figure, we scaled the penetration test up essentially by an order of magnitude. And came back in the new year with a, you know, much bigger team, much bigger scope, and a freshly delayed Windows Vista. They actually delayed Vista to facilitate the assessment. So at this point, I was going to show you a T-shirt, which unfortunately is put away so safely that even I can't find it. I will describe it at least. Imagine the Windows logo. Above it, it says, "I delayed Windows Vista." Signed by Brian Valentine, the VP in charge of Windows Vista development. He did actually tell us when he was signing them that he didn't want to end up seeing them on eBay. I don't think BlackHat's quite what he had in mind, but I think not showing it's in the spirit of that at least. But yeah, it was great. The fact that Microsoft pushed back the release of Vista to facilitate our assessment, to give us time to do what we were doing, phenomenal. So, as I said, our initial focus was on new features. Once we'd covered all of the high-risk code, we actually went back to Microsoft and said, look, you're leaving some fairly gaping holes here. There's, how about this SMB stuff? That's not in scope. You might want to look at that, guys. As it turned out, once we covered all the high-risk code, we were allowed to increase our scope to particular features that did concern us. SMB, I could not face that code. I really couldn't. It's such an ugly code base. I have ultimate respect for the folks that did end up reviewing SMB. I don't know if Felix is here, but yeah, the guy deserves a medal for code reviewing that. Another great source of problems was NTFS. Our understanding at the time was that NTFS was actually completely unmaintained by Microsoft. That it was such an ugly code base and such a nightmare to work with that the team had all left, that there was nobody left working on NTFS, and that anytime a bug came out, it was kind of touched with kid gloves only just as much as was necessary to fix the bug, hopefully without the whole house of cards crashing down. So again, it was kind of an interesting code base to try and review, and lots of cruft in there. One of the things that we all kind of pretty much universally agreed was that Windows could actually be made a whole hell of a lot better if we just removed all of this crap. I would dearly love to see a Windows Lite without all of this old crafty code, with just the new shiny .NET, Stack Overflow prevented code. I think it would be a great product. In general, our scope was to follow the rat holes. Now, what I mean by this is, quite often, actually, we'd start interviewing a team and we'd get a sense that something wasn't quite right. And 99 times out of 100, that sense was correct. So we were strongly encouraged to follow that. If we had an idea that there was a lurking bug that was kind of buried under half a dozen layers of abstraction, we were positively encouraged to go follow those rat holes, to find out where those tunnels led and what the eventual outcome was. Was there a security bug or not? So this leads to our second shirt. This is the official Windows Vista shirt. If I just hold it up here. So you got the Windows Vista logo on the front, pen test team on the sleeves. There's an H.P. Lovecraft quote on the back. Searchers after horror haunt strange, far places. That's a direct reference to this concept of rat holing, that sometimes we were looking for horror, and sometimes we ended up in some very, very odd places in the Windows code base. It's grim in there, I tell you. So, okay, the bug bar. This was ultimately what we were working towards. The bug bar at Microsoft is a document that basically says, if you have a security bug, here's how to classify it. You break it down. Is it local? Is it remote? Well, if it's local, then that's probably lower severity than remote. If it affects few people, then it's less severe than if it affects many people or administrators. This kind of thing. Bunch of fairly simple criteria that, once you can classify your bug according to these criteria, you just say, right, that's my severity, no arguing with it. It was actually a really, really handy tool, because quite often we'd find bugs that, we'd have a little argument about, where it belonged in terms of the bug bar, but by and large, it was great to just be able to say, hey, we've got a remote code execution bug. That's critical. You got to fix it. End of story. No discussion whatsoever. There was actually a line drawn on the bug bar that said, anything more severe than this line, anything that's above this, we're not going to ship on Vista. So if you have vulnerabilities that are above this severity, you will be removed from the DVD if you don't fix that by release date. So spectacularly useful tool for us as pen testers, because we could say to folks, we could go to teams and say, look, you've got a remote code execution bug here. That's critical, which means you ain't making it on the DVD unless you fix this. Very, very cool tool. It did have limitations, though. It's one of those things that it cut both ways. A great example of this We found a bug in Bluetooth. I'm not going to say any more than that, but it was a bug in Bluetooth. Not your average buffer overflow, certainly not easy to exploit by any means. We had a lot of back and forth with Microsoft about whether or not it was exploitable. We created a rather slick demonstration for it and eventually won the argument on whether it was exploitable or not. So it then came down to whether or not it was remote. And the thing of it was that I mentioned the line on the bug bar. With this particular bug, it came down to if we classified it as a local bug, it was below the line and it wasn't going to get fixed for the Vista DVD. If we classified it as a remote bug, then it was above the line and it would have gotten fixed for the Vista DVD. The eventual conclusion was that it was remote by about 20 feet, which wasn't remote enough because that's close enough to physical access, so yeah, it wasn't fixed. We can argue a lot back and forth about whether that was the right decision. To be honest, I would probably change my mind if I was in exactly the same situation again today. But the point of it was it's a great case study for how bug bars can fall down sometimes. In order to be comprehensively useful as a tool, it has to cover every possible scenario. So you will come across scenarios that don't fit cleanly into your bug bar. And the way that we like to recommend to folks that they solve this is that you have an option on the bug bar that just says other. And you have to argue about it. You have to fight your case to get whatever classification it is for that bug. But the point of it is, once you've classified a bug as other, it forces an automatic reassertion of the bug bar, that you have to reevaluate it and reconsider whether you are actually considering every possible eventuality. So yeah, the bug bar was a good tool. It had its occasional problems, nothing that couldn't be fixed, and in general, yeah, it was great. I certainly appreciated having it. So what were the outputs of the review? Well, first and foremost, lots and lots and lots of very nasty bugs. We prevented a lot of bugs from shipping in Vista. I'm proud of the number of bugs that we found and got fixed. We certainly helped with remediation. We helped with verification of the fixes. We did not help with remediation. So, as far as I know, none of our code is anywhere in Windows. We weren't kind of contributing to that level. But certainly once the team had a fix, they would come back to us and we'd verify the fix. Code or binary if necessary, whatever it was. On that basis, we were, highly optimized. We were, focused purely on attack. With the odd little bit of defense here, but because we were focusing so heavily on attack, we covered a lot of ground very, very quickly. And if you actually do the math on how many bugs we found and $250,000 per bug and how many consultants there were and how long we were there for and how much we cost, Microsoft really got good value out of it. At one point, we were actually referred to by someone nameless at Microsoft as a rape gang. We were beating Windows up to such a degree. It was kind of crazy. Other things that Microsoft got out of the review was some superb documentation, and I mean truly superb. One of the main criteria for passing the FSR was that features had to have complete threat models data flow diagrams. If they didn't have this documentation, then they didn't ship on the DVD, period. So, we had folks on the team that, all they were doing was sitting reviewing threat models for months and months and months. I felt kind of sorry for those guys as well, because it's not the most fun job in the world. But like I said, at the end of the process, Microsoft now has threat models for everything, which is great because I'm actually a huge fan of threat modeling. I think it's a very powerful tool. You can take feature A and feature B that interact in some way, and you can resolve the threat models against each other and figure out whether there's any potential security problems there. Being able to do that by having all of that documentation is very, very powerful. Another thing that Microsoft got out of it was a lot of fresh rules for prefix and prefast. So these are Microsoft's automated code review tools. I forget what the difference is between them. I think one runs before the preprocessor, one runs after the preprocessor, something like that. It's essentially these are spectacularly powerful code review tools that I really wish Microsoft would share with the rest of the world, because they really are very good. So yeah, we came out with, I don't think anyone on the team actually wrote the signatures ourselves, but certainly, there was a lot of bugs found that ended up being ported to prefix and prefast rules. Okay. Okay. So apparently prefast is in the C compiler. Okay. Okay. So yeah, lots of new code review, automated code review tools, a lot of improvements to the process. This was the first time that Microsoft had ever done an FSR involving external consultants. So to some degree, the process was still new, it was still evolving, and we contributed a fair amount to the design of that process. And then in general, lots of knowledge about where there's holes in Windows. Lots of good places that you could just take a bucket and spade and start finding ODay. Just lots of general purpose knowledge about which bits of Windows are good and which bits of Windows are not so good. So, lots of good stuff in addition to just the bugs. Some interesting tools that we came across. Microsoft has a thing called the Fuzzer Common Library. They don't actually abbreviate it to FCL, they abbreviate it to FUCL. I kid you not, the FUCL. So, FUCL is, I can't call it that anymore. FCL it's a general purpose fuzzing engine. So the idea of it is, if you've got a file format or a network protocol, you generate this XML document that describes the protocol of the file format, and you give that to this fuzzing engine. Now the engine has all of the cases in it for, here's a test case that looks for this specific type of integer underflow. Here's a test case that looks for a fixed length buffer of this kind. You've got all of the intelligence about what test cases to generate in FCL, and then you've got the XML that describes how to inject those test cases into the actual application. Very cool tool. The rule at the time, and this may have changed since, was that any part of Windows that was processing a network ultimately that opened a network socket or that parsed a file had to pass a very intensive FCL run. So they, hundreds of thousands of test cases, days and days and days of fuzzing, and it had to pass completely clean before it was accepted. So very, very cool tool. A lot of these file formats are spectacularly complex, and FCL is really good for raising the bar on the low-hanging fruit there. FUCL. Can I what, sorry? An intensive FUCL run. It's wrong. No. Another tool that we came across was a thing called X-Ray. X-Ray was a very neat tool that basically what it did was it traced security through Windows in the form of data or access control or whatever it could get a handle on, and allowed you to summarize very, very complex interactions in detail and just say, hey, there's a problem here because this privilege comes in here and it's over there and you can do this and that and the other, and hey, you got a bug. This was one of the things that it could have been legit, it could have been bogus. We weren't actually allowed to play with it, so it's possible that it was a very, very cool proof of concept that didn't actually work. So who knows? It certainly seemed like a very cool tool to me. Oh, X-Ray is actually public now. Oh, awesome. I'll have to check that. I did actually Google for it and I couldn't find any reference to it on the internet whatsoever. Ah, okay. So what is it called now? Ah, okay. So apparently it's changed name, but everyone still calls it X-Ray except for publicly. Thanks for that. Really. So I mentioned that, predating the Vista engagement, I found these shatter attacks. Vista was the first OS that Microsoft had released after Shatter. So, this was the real opportunity to fix the thing. And it included essentially a GDI firewall. So you have, a network firewall that selects which protocols to allow to which servers. Well, there's a mechanism in Vista that essentially decides which GDI messages are allowed to be sent from which process to which process, so-called integrity levels. Of course, I wanted to look at this. I wanted to take it apart. I was basically told no. The reasoning that I was given was that, everyone knew that it was broken. It was accepted that it was broken. It was accepted that it didn't work. But it was a check mark in a box to make Brian Valentine happy. Yes, we have a fix for that. So, yeah, I was basically told, please don't waste your time on it. We know it's broken. Just don't bother. So I didn't look at it. And then, as expected, when Vista was released, this was broken fairly quickly because the main way in which it's used is to provide another sandboxing mechanism for Internet Explorer. Well, we all know how that turned out. At the time I released it, I'd actually called Shatter unfixable. I actually still stand by that, even though I took a lot of heat for it at the time. Having seen what was done with it in Vista, it's still kind of fun. You have to kind of design around shatter attacks. One of the things that was very fun for me on the FSR though was to meet the developer who patched it. The way that the bug had actually been released, initially, this was way back in 2002, it had been kind of a battle to get Microsoft to recognize that it was a valid bug, and effectively I ended up zero-daying them in order to force the issue. And meeting the developer who patched the flaw was fascinating because, I had just zero-dayed Microsoft. And I was, a little awkward and uncomfortable and worrying about lawsuits that were coming back because I just zero-dayed Microsoft. The developer who was on the other side of that, as it turns out, was just as terrified as I was because, he'd just been zero-dayed. So it was kind of fun to see how both sides of this really bad bug had just terrified everyone involved. There was no one that walked away from it with any feeling of comfort. Other fun stuff that we checked out with Vista. Hell's yes, we searched for profanity. Searched for every swear word under the sun in the Windows code base. There is surprisingly little profanity. We actually ended up making much more use of bug or fix me. Anytime that you see a comment containing the word bug or fix me, yeah, we had some fun there. We actually had an internal competition within the team for the most obscure chunk of Windows source code. I tried to remember some of these, and they're so convoluted that I wouldn't do it justice. You cannot imagine some of the things that we were seeing in there. Just mind-blowing stuff. Comments like, we add one here. We don't know why we add one here, but if we don't add one here, it breaks, so we'll add one. Yeah, what do you do with that? More fun was had, finding the patches for our own bugs. I certainly had fun. One of the first things I did was look up the fix for WM Timer, which was the shatter attack. And I'm reading through the handler for WM Timer, and I see the fix. And just above it, there's this comment saying, we have to check for non-zero values here because there are very bad people out there. Yes. I was actually gutted. I formally requested from Microsoft that they allow me to keep that one-line comment just so I could get it printed up on a t-shirt and say, yes, I am a very bad person according to the Windows codebase. But no, apparently that's too much source code and yeah, couldn't share that with the public. So what are you going to do? But yeah, Windows says I'm a very bad person. I'm okay with that. In general, I have to say that the team that was assembled for this engagement was spectacular. Both from the Microsoft side, Microsoft has some spectacularly clever people. They really do. They've hired a lot of very, very good people who really know their stuff. And all of the consultants that were there as well were absolutely top-notch. Flown in from around the world, really, really good people, really good friendships made. Yeah, it was a real privilege to be part of the team, and I'm really glad that I had that experience. So, in conclusion then, was Vista secure? Let's kind of revisit this. Well, as I said, if security is a process, not a product, then Microsoft sure as hell deserves a lot of credit for SDL. They really do. Bringing us in to codify the FSR and to actually test what they'd done with SDL and with Vista, it was a huge gamble for them. It really was. It could have gone spectacularly wrong in many, many ways. It didn't. It turned out pretty good, other than certain people getting up on stage at BlackHat a few years later. They deserve a lot of credit. I mentioned earlier that Microsoft has this reputation for bad security. There's other companies out there that really deserve that far more than Microsoft do. You know who I'm talking about. Flash. So ultimately, yeah, SDL is fabulous. I'm a huge fan of SDL. In general, at Recursion, we're huge proponents of it. We love it. It's a great process. It has its limitations, as everything does. In our case, we do a lot of hardware assessment, hardware design, hardware penetration testing. So, there are certain ways in which SDL doesn't really work too well for hardware. One good example on this is patching. If you imagine the security, the cost model of Microsoft deploying a security patch, there's a fixed cost to develop the patch and QA it and test it and all the rest of it. And then they push it out, and it scales immediately to as many machines as they need it to. Well, if you think about that in hardware terms, that doesn't quite hold true anymore, because if you've got a hardware vulnerability, you can't just send someone a patch. You're not just going to mail someone a new PCB and expect them to dismantle whatever it is and drop that in. So you've now got the cost of a service engineer. You can't just patch someone for free. Likewise, that cost scales with the number of devices in the field. It's not just one cost to develop one patch that then scales to as many people. Your costs scale with the size of your deployment. So, as I said, at Recursion, we're working on extending SDL and threat modeling in all kinds of hardware-centric ways that just weren't relevant for Microsoft. Ultimately, there was a lot of very nasty bugs that did not ship in Vista as a result of our assessment. That's all there is to it. Even if you argue that we only found low-hanging fruit because, maybe we weren't going into as much detail in some of these features as we'd like, either way, we got a lot of low-hanging fruit, and I mean a lot of low-hanging fruit. So, was Vista secure? To be honest, I don't know how to answer that question. I don't know how to answer that question about anything. How do you ever say that anything is secure? So again, you come back to the idea of security being a process, not a product. If security is a process, Microsoft has security right. They really are doing it right. So Vista was a giant leap in the right direction for security process and just security overall. They really deserve credit for it. So when I sent the slides to Microsoft, I invited them to bring someone up to respond for a few minutes. I don't know if anyone does actually want to follow up on that. If not, we'll just have a few more minutes for Q&A. Anyone from Microsoft want to take the stage? I don't know, whatever you want to say.
It's your talk, not ours.
Okay, fair enough. Alrighty, well, I reserve the right to redirect questions at you all. So, questions? Yes, at the back.
Did Windows 7 receive the same scrutiny that Vista did, or did they perhaps scale back a little bit using most of the Vista code base?
So the question was, did Windows 7 receive the same scrutiny? My understanding, I wasn't actually involved in the Windows 7 review. My understanding is that for Windows 7, it was actually significantly extended in scope. So in addition to all of the new code for Windows 7, they actually included all of the legacy code in all of the risk analysis and penetration testing and everything. So as I said, my understanding is that for the limitation that we faced in terms of new code only, that only applied to Vista and did not apply to Windows 7. So yeah, 7 should have received the full coverage as far as I'm aware. Yes?
Check the 64-bit version of Windows Vista. Was it significantly more or less buggy than the 32-bit?
In general, a lot of the bugs that we were finding were kind of architectural issues. So 32, 64-bit didn't really make a difference. I think it's probably fair to say that given that we found issues that were derived from incorrect handling of 64-bit data, those bugs will never affect 32-bit code, and there is no vice versa for that. So you probably could argue that the 64-bit code is less secure just because it has a new class of bugs that doesn't affect 32-bit code. But in reality, there's no tangible difference between them. To us, it was all the same code base. Really no significant difference between 32 and 64-bit. Yes.
Numbers to support some of the argument, like the number of security bugs found before, the number of security fixes that had to go in after it shipped.
So the question is, do we have any metrics to back up our assertion that this was a good process to go through? The thing of it is, that's kind of a tough question to answer, because it's not necessarily about the number of bugs that's found, as much as how hard was it to find those bugs, what level of skill was required to exploit them, and ultimately, was it as severe as it could have been? So it's very difficult to point to even a methodology and say, here's a methodology that would allow us to say what we did improved Vista. But the simple fact is there are a lot of bugs that didn't ship in Vista. So whatever you can argue in terms of metrics in and metrics out, a lot of bugs got fixed. That's all there is to it, really. Yes.
Any idea if they'll be extending this to, say, Office or Exchange?
I don't know, to be honest. The question was, is there any plan to extend this to Office or Exchange? From my perspective, the review that I was involved with was run by the Secure Windows Initiative. So effectively the Windows side of the house, and things like Office and Exchange just weren't in scope for us. Given the progress on the review and the kind of outputs that they saw from it, I wouldn't be surprised if they have started deploying to other products. Perhaps someone from Microsoft can comment. Thanks, Mike. Thanks, Mike. More questions? Yes.
Just to talk about the value, Chris, you could probably say that even after Microsoft's internal teams did a lot of review, the consultants came in and still found some bugs.
Yeah, it's a very good point. As Forrest was on the Vista team as well, and he raised a very good point that what we were doing was after all of Microsoft's own internal security. So, this was literally the final stage, and they'd done everything that they possibly could internally, and they honestly expected us to come in and not find anything. I think that's a fair comment, wouldn't you say? Yeah. So, the fact that we found so much was a surprise to us and a surprise to Microsoft. Any more? Oh, another question.
Microsoft continues to patch monthly on Vista. Is there anything that surprises you that you didn't find?
Not really. Microsoft continues to patch Vista on a monthly basis. Is there any bugs that I've seen that surprised me? No, although I do crack a smile whenever something comes out that I thought, yeah, you guys really sucked. You deserve that one, kind of thing. But yeah, I mean, kind of tough to answer, to be honest. That wasn't really much of an answer, I'm sorry. Did that answer your question to any real degree?
We can talk later.
Okay, sure. Yes?
How much of your review was done with source code versus
So the question was how much of the review was done from source code versus binaries or other. In general, we started with an architectural review and then used the source code to back that up. So, if we talked to a team and were satisfied with their answers and they were really on the ball and, really knew what they were talking about, we wouldn't touch the code. But if something didn't seem right, maybe we had some questions that we didn't get the answers we were hoping for, at that point we'd dive into the code in as much detail as we needed to. So, yeah, it was always there for us. We could, just sit and read through it in as much detail as we wanted. But I think certainly I used it as a kind of a secondary data source, the primary being the actual people writing the code. Yes, at the back. So the question was, what was the skill set mixture and how did we pick the team? We didn't actually pick the team. Microsoft selected 3 or 4 leading penetration testing companies and brought us in. I'm not sure if there were individual resumes reviewed on Microsoft's side. I suspect there was. Can anyone confirm or deny that point? Did you guys review our resumes before we came in? There we go. So yes. In terms of skills, primarily code review, architectural review, just general purpose hacking, really. Most of us, as I said, were brought in for code review reasons. So, yeah, lots of knowledge of C, basically, was the primary skill, for sure. Any more questions? Yes? So the question was, did we look at both the kernel and user space? Yes, we covered everything. Everything. The only major, well, beyond what I was saying about not reviewing the legacy code, the other big chunk of stuff that we didn't look at was drivers. But yeah, beyond that, certainly all of the kernel was in scope, all of user space was in scope. Any time that we were testing a feature that had some impact on the kernel, yeah, we absolutely had the source code, and we're encouraged to go look anything up, whatever part of Windows it was in. There was actually a fair amount of concern expressed at the end of the engagement because we'd spent many months getting to know Windows in a phenomenal level of detail with all of its various nooks and crannies, and then left. And Microsoft were a little bothered by the fact that all of this knowledge about Windows was just walking out the door. But yeah, we absolutely looked at kernel space, user space. There was a lot of interesting conversations happened about people figuring out different artifacts of how the Windows kernel actually works, and pennies dropping mentally and things clicking, as it were. So yeah, absolutely, the kernel was in scope. Yes. Did all of the vulnerabilities get patched? I don't know, honestly. We finished our review a little while before Vista went gold, so it's entirely possible that everything that we found was fixed. It's also entirely possible that everything that wasn't fixed on the day that we left wasn't fixed on the DVD. I really can't comment. Yes, question at the back. Right, so the question was, did we have discussions with Microsoft about the size of the attack surface and how it grew with Vista? In some specific instances, yes, but in general, in the general case, we were brought in for the very final stage of the process. So by the time that we were brought in, the idea of the expanded attack surface had already been discussed ad nauseam and, had been accepted and whatever. So in some cases, yeah, we did find, specific issues that our recommendations were that, just close off this little chunk of attack surface. So yeah, I mean, that was definitely in scope for us, but I don't think it was a primary driver of the review, because, like I said, we were brought in at the very end when all of those discussions had already been had. No more questions? Huh? Perfect. I'm a few minutes early then. All right. Thank you.